We present PeckVis, a visual analytics tool for social scientists to examine dominance hierarchies. The tool has two interfaces, one for examining hierarchies formed by a single group of subjects, and one to compare multiple groups. We start with the single group analysis. The interface for analyzing a single group has multiple panels. The group selector allows us to select a species from the drop-down menu, and then different groups of that species can be selected, with the circles representing groups. To assist the selection of groups, the user can choose to display certain metrics below the circles. He or she can choose to show the number of interactions, number of states, number of triads, and more. The summary view has two panels. The first summarizes states with the class occurrence frequency or COF, and class stability factor or CSF. The user can select states for analysis from this table. The second summary shows the interaction matrix for the selected group. This matrix summarizes the interactions between subjects in the group. Next, we have the detail views. The first panel shows the state sequence, which is a sequence of the different hierarchy configurations the group forms. The number above the state indicates the state ID, and the number below it indicates the number of interactions that the state contains. Additionally, markers above the state ID indicate certain characteristics, such as cyclic states or all dominate one states. The state sequence is expanded to a more detailed state variant sequence in the panel below it. This state variant sequence also has the state IDs labeled above states, and interaction count labeled below the state. As described in the paper, in each variant, the nodes represent subjects in the group, with their position indicating the eventual rank of subjects, and color indicating instantaneous rank. Tracking the node color across the sequence allows users to identify variants in which rank changes occur. Additionally, visual cues on the links between nodes indicate new and reversed relationships, thus allowing users to deduce the cause of the new state variant. The next panel contains the music notation. This representation shows the interaction sequence. Here, the horizontal lines represent subjects, and the vertical arrows indicate interactions. The arrows are colored based on the attacker's ID. Additionally, we use markers above the topmost axis to indicate the interactions at which a new state occurred. When used along with the state variant sequence, the user can investigate the interaction that caused a state, how many times the interaction was repeated, and if it occurred in bursts. The final panel shows the rank evolution chart. Here, converging or intersecting lines indicate that two individuals are competing and exchanging rank. This chart is used in conjunction with the other panels in the detail view, to identify periods of competition in states or variants. Now, let's observe the interface in action. Let's investigate Chicken Group 10. Going over the COF and CSF table, we see that for State 1 and State 2, the stability is 1, indicating that they were the only configurations formed in the 1 linked class, and 2 linked class respectively. Moving further, we see that in the 3 linked class, 2 configurations 12 and 14 are formed. Let's investigate these configurations. We see that state 14 occurs before 12 in the state sequence. From the state variant sequence, we gain additional insight. We see that the transition from state 14 to 12 occurred due to the reversal of the interaction between subjects 1 and 3. Additionally, based on the node color, we learn that the instantaneous rank of subject 1 increased over that of subject 3, as a result of this state transition. This is also evident from the rank evolution chart. To investigate further, we select the 2 states that occurred before state 14, and observe the music notation. We can immediately see that subject 2 is bursting against subject 4 during these states. Going back to the relationship between subject 1 and 3, we only highlight their interactions with the balloon plot. We see that subject 3 attacked 1 in the first interaction of the sequence, and then subject 1 retaliates after a while, causing the formation of state 12. By looking at this relationship across the entire interaction sequence, we see that subject 1 continues to dominate 3 without any retaliation. Similarly, we investigate the 6 link states, 38 and 39, of this group. We see that most of the interactions are in state 38, so let's focus on this state. We immediately observe that 2 variants, 38.7 and 38.1, were formed in this state variant sequence. This is evident from consecutive highlights of the same color in the state variant sequence. Again, based on edge markings and node coloring, we observe that the variants are formed due to competition between subject 1 and 2. We see that subject 1 dominates 2 more than the reverse occurring, thus causing subject 1 to earn an eventual rank of 1. Experts analyze the data of other groups by following this procedure of selecting states based on their occurrence and stability, and then examining the states in detail through selections made in the state and state variant sequence, and music notation. Now, let's see how groups are compared. The interface for comparing groups has multiple panels as well. Just like in the single group panel, we have a group selector. The only difference is that users can select multiple groups with this panel. Again, the summary view has 2 panels. The first summarizes states with the class occurrence frequency or COF, and class stability factor or CSF, like in the single group analysis. But as shown here, the user can use this panel to show a list of state or state variant subsequences that appear across the selected groups. The user can select these subsequences for analysis from this list. The second summary shows the MDS plot for the selected species or multiple species. This plot can also be used to select groups for comparison. Finally, we have the small multiples view. Here users view the selected groups as small multiples of a visual representation of their choice. They can select from the state sequence, state variant sequence, music notation, balloon plot, or rank evolution. Now, let's compare some chicken groups with the interface. We start off by selecting groups based on their similarity in the MDS plot. We will use the dynamic time warping, or DTW distance to compute similarity. Now, let's select these similar groups clustered together in the center. We will also select this outlier, which is group 5. The balloon plots do not show any glaring dissimilarities, however, we do see that in group 5, except for the top rank subject, the others received a similar number of attacks. Looking at the rank evolution chart, we see that each group is different in terms of how rank evolves. But the outlier group, group 5, is more different as it shows 3 individuals competing with each other, unlike the other plots which show 2 individuals competing. Moving on to the music notation, we immediately observe that the outlier, group 5, has a very large burst as compared to the other groups. Let's use the same scale across all the charts globally so that they are more comparable. Now, on closer inspection, we see that markers at the top of the music notations inform us that the outlier group has a significantly larger number of states at the start of the sequence. This indicates that there is a lot of competition in the group as seen in the rank evolution chart. These music notations still do not tell us why the other groups are similar. To investigate further, let's use the state sequence. On first look we do see some commonalities, let's use the subsequence list to investigate them. We see that the subsequences state 1 to state 4, and state 30 to state 38, occur in 3 groups, the 2 groups 1 and 12 that are the closest in the MDS plot, and the outlier group. On further inspection, we see that group 1 and 12 also have states 10 and 16 in common, thus making group 12 a subsequence of group 1. We also see group 5 has a series of states that are not present in other groups, thus causing it to be classified as an outlier. Experts examine the state variant sequence in a similar manner to investigate similarities and differences among groups. They found that in addition to forming the same states, the two most similar groups also form the exact same state variants. The outlier, on the other hand, formed different variants of the common state subsequence. In a similar manner, experts used PeckVis to examine other groups. They made findings about the states and state variants formed, such as the most frequent and stable hierarchies and variants, and the way a species transitions through those hierarchies.